Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 8. Students, in this lecture, this is the last lecture, okay, of flat slab design, and here we basically provide flexion and shear reinforcement detailing. Okay, we will design as well as we provide shear and flexion reinforcement. This is the most important lecture of whole series, you can say, to understand the placing and designing practically. Okay, here I am showing you the practical approach, how we basically provide the final working drawing. Okay, so to before start the flexure designing of flat slab system detailing, first of all I want to share with you a one very wonderful video. Okay, students, basically this is a panel. Okay, and in this panel basically you see this direction is my east west direction. Okay, which is the longitudinal direction, and east west. Okay, and this direction is the north south direction. Okay, this is north south direction or the transverse direction or the short direction. Okay, so you must remember, first of all you see here that, remember, they're just uh, placing the spacers, or you can say shear blocks, okay, which provide a clear cover to the bottom reinforcement or spacer, okay, concrete spacers. After that, they will place the bars in the longitudinal direction. This is very important. Okay, why they are placing the bars in the longitudinal direction in the bottom portion? This is a very important question. Okay, because in normal slabs, as they are beam supported slabs, we see the bottom bars are placed in the shorter direction, but here they are placing the bars in the longer direction. I will answer you inshallah in coming part. First of all, they are placing bars. This is called lower reinforcement in the longer direction. In the longer direction. Okay, this is important. And you see here the positive reinforcement you will see. Okay, this is very interesting and it is a very wonderful video. And I will design all these bars. Okay, I will design all these bars, and these are the extra bars, additional reinforcement for positive reinforcement. One thing you must understand here, this is very important to understand. You see in this region, they are basically placing the bars. Okay, you see this is the column strip area. This is the column strip. Okay, and the spacing is maximum. You see the spacing is maximum or larger, but this is the middle strip area. Okay, and here you see basically we have maximum positive movement, so that's why the spacing is minimum. Okay, and here again we have column strip. Okay, in the column strip region you see in the longer direction there is larger amount of spacing. If I show you here, this is important to understand. Remember, this is my longer direction. This is my longer direction, east west direction, and in east west direction you see the extra bars which I am placing. Okay, where I need it I place extra bar. And you see in the column strip region, although this is my longer direction, and I basically here the demand is maximum in the column strip region for positive reinforcement. Similarly, this is my now middle strip area, and here I am providing number 5 at the rate of 20 center to center. Then again here my maximum movement, because in this region, in this column strip I have maximum movement. Okay, so that's why I'm placing. Okay, because there is almost a movement here is 17 k feet and here is 17 k feet, and there is I think so almost 10 to 9 k feet movement. Okay, so basically in the demand is lesser. Okay, so that's why I'm using larger amount of larger spacing, but here is 6 inch into the center. And again in the transverse direction, now you will see in this video the detailing of reinforcement which is provided in the transverse direction. Remember, here you see bottom layer of steel for positive movement in east west direction, and here you see bottom layer of steel for positive movement in the north south direction. So let us see in this video. You see these are the bars which they are providing in the north south direction. Okay, these are the bars which they are providing for the north south direction or transverse direction. And you see at second lower reinforcement in the short direction they are providing the bars, although this is depend upon the panel. Okay, this depends upon the panel. You see, this is the middle strip area, and they are providing a minimum spacing. But although what we have, I place the reinforcement in a uniform manner. Okay, I'm not just following that kind of pattern. So you see here in the column strip I am providing number 5 at the rate of 10 inch into the center, and here I am using in the middle strip number 5 at the rate of 12 inch into the center, and again in the column strip I am placing a number 5 at the rate of 10 inch into the center. Okay, so this means that the movement is maximum in the column strip, positive movement in the north south direction. Similarly, and remember, this is very important to understand that the north-south direction bars are on the top of the bottom layer. This is important, okay, to understand. And similarly, now you see the detailing, okay, and now they are basically placing the shears for the top layer. Now you will see the top layer. So they're placing the shears, okay, and after placing the chairs, these are the special bars which is placed over the chair for you can say for holding the top layer. Okay, this is very important video, and inshallah you will see it will be very helpful to you understand the rest of the part of the video. It's a very longer video, almost 1 hour video. Remember, this is very important. This is very important to understand in this step. Okay, you see the shorter bars are placed first. The shorter bars are placed first, okay, upper reinforcement net, and then once they place this reinforcement, then they basically provide the longer reinforcement. Why? Although it should be needed that the shorter bar should be placed on the top and the longer bar should be below of this net mesh. Okay, and these are the extra bars which places for the negative reinforcement. Remember, here negative reinforcement is very close and negative movement is very large. Okay, and now you see they will placing the bars in the longer direction, negative reinforcement. Remember, this is called negative reinforcement, which is provided for the this is upper reinforcement in the upper reinforcement, but for negative movement. Remember, and remember in the column strip region now they are placing close bars, because in the column strip area now negative movement is dominant. And if I show you here, these two basically is my bottom bars detailing, but here I have here, you see now, you see negative reinforcement number 5 at the rate of 4 inch center to center. Okay, this is closer. Here the reinforcement is very closer near the column region, and this is the in east-west direction. Okay, and this is the steel which is in the north-south direction. These blue bars are in the north, and you see this closer spacing near the column. So you will see the full detail. Okay, and this will be very helpful. Okay, so let's come to the main topic, and the cross section is prepared. So let us explain and see what we have in this lecture. Okay, so in last lecture basically that was lecture number 6. We designed basically for the movement which we got in step number 6 or in lecture number 6. And you see all these steps. Okay, so please watch lecture number 6 to understand this lecture number 7. And finally we got this reinforcement, but there is very important thing, as we got our S max which is equals to 20 inch and AS minimum which is 0.216 inch square per feet. If we find out the spacing for this amount of reinforcement, here you see, so I got basically 17 inch. So 17 inch is now my S max. Remember, this is very important point. Okay, 17, I can't increase the bar spacing more than 17 inches, not now 20 inches. This is very important. Okay, and let's see further what we have. We basically in north-south direction we categorize these movements in lecture number 6, and similarly in lecture number 6 we in east-west direction. Okay, And remember, this one is basically our let me show you here. This is our, remember, this is our EW frame. Here you see EW frame. This magenta color basically representing the mid line of the panel, which is the, you can say, the mid of the middle strip. The distance between in two, this is basically column strip width for exterior frame, and this total from this line to this line, this is the column strip width for interior frame. And similarly, the distance are the length in between this line and this line, it is basically the mid strip width. Similarly for all. And similarly, I represent here, this is my in-is frame, and in ins frame, this blue line representing the middle, this is the middle line of our middle strip. This is this distance is basically our the width of the column strip width in ins direction for exterior frame. And similarly, this, the distance between this line and this line, this is the middle strip width in north south direction frame. Okay, and similarly this panel and this panel representing the column strip width for interior frame. So I have to now represent the movements, and the movements which I have represented, first of all I have providing the bars for positive reinforcement, or you can say the bottom bars. Then the let me show here. First of all, I will provide, basically let me show you, this is my slab system. Okay, this is my slab system. First of all, I calculate and I will provide the bars in bottom, then the bars, the transverse bars in the top, then I will calculate the negative bars. Okay, and then I provide the crossbars for those negative bar. Okay, so first you will see these bottom bar. So let me show you here. Here we have basically bottom layer of steel for positive movement in east-west direction. Okay, this is in east-west direction, remember, not in north-south direction. Okay, so please remove this. Okay, this one should be removed. Okay, now here you see that for corner, okay, for corner, remember I have representing, this is my column strip and this is column strip in north south direction, but this column strip in east west direction. This is this middle strip in north south direction, and similarly this is the middle strip in east west direction. So you have to represent these lines. Now here you see in the diagram, let me show you in the diagram. This is very important to understand. Remember, this is the best lecture. Okay, and you will understand here. Okay, the movements, basically you will understand the bar placing, how we practically provide. Okay, this is a practical approach basically as we did in site. So we are placing the bars in corner panel for this movement right now. This is all about 60. Okay, so here and remember, there you see there is zero positive movement. So here we will use the minimum reinforcement, and for that purpose I basically place number 5 at the rate of 12 inch center to center. Although you can place this bar number 5 at the rate of up to 17 inches, you can place, but I am placing 12 inches. Why? Because here these red bars basically is my main bars, which will be provided for positive 16 kept fit movements. Now these bars is placed at a distance of 6 inch center to center. Remember, these bars are placed, let me show you. You see the spacing is 6 inch center to center. This is the bar you see here, where it is representing, although I did not represent these bars, but yes, this was the spacing, and this is 6 inch center to center. Okay, number 5 at the rate of 6 inch center to center, and this line is basically representing the north south direction bars. So let's see, control Z. This is not okay. Yes, here we have, and this is top reinforcement. So although these bars are not represented here, but you can represent these bars. That let me represent this. Okay, the bar which is provided up to the end is how you can represent this. Now you will see. Control Z again. Let me show here this one, and please close this from this point to this point and close these snapping. Okay, now you have to double click this, and then you will write this is number 5 at the rate of 6 inch center to center. Okay, 6 inch center to center. Now remember, here you have to select one bar, and here you have to enter circle. Okay, and here you have to enter 1 inch diameter, and this bar should be colored. Let's say we will using by layer. Okay, by layer. Okay, so now this means that these bars, the circle means the bar which is placed in this direction is number 5 at the rate of 6 inch into the center. Okay, this is only for this middle strip in east-west direction, and similarly for this as well. Here you see these bars, these red bars, basically these red bars are number 5 at the rate of 12 inch into the center, and these bars which is closely spaced are number 5 at the rate of 6 inch into the, but they must be provided within the column strip width, that is 5.58 feet. And after that, in this area you see the column strip of the north-south direction and the column strip of the east-west direction. Here the main bars are, these are the positive bars, and you see here in this diagram it is clear that theoretically we know there is zero positive movement, so we will provide minimum reinforcement, and that you see number 5 at the rate of 12 inch center. Although you can keep these spacing of these bars up to 17 inches. Okay, but why I'm using, because here my main bar spacing is 6 inches. If I provide different reinforcement here, then the adjustment of this amount of reinforcement will be difficult for me. Although this movement is 16 kip, so if you want to check that whether here the maximum movement is 16 kip. So if I'm placing number 5 at the rate of 6 inch into the center, so let me check it. Okay, how you will check? We will use this formula. Number 5 at the rate of 6 inch will give me an AST. Remember, will give me an AST from spacing formula. Number 5 area is 0.31 divided by 6 times 12. It will give you how much amount of steel. Please take up your calculator. 0.31 divided by 6 equals you got 0.62, mean that 0.62 inch square per feet. This is now your AST. Then you have to plug this AST here. Okay, let me check it. 0.9 times 0.62 times 60 times into bracket, D is my 9 minus, and A is FY 0.62 times 60 divided by 1.7 times FC prime, that is 4 KSI times B, that is 12, and bracket close. I got 286. You have to divide this by 12. You got 23, almost 24. So this is far away, you can say, from 16. So this means that you can increase the spacing as well, because the maximum movement in this strip is 16 kip. So you can increase this to 7-8 inches. Okay, and then you have to check your capacity through this way. Okay, if you are using 8 inch, then you have to plug 8 here, calculate AST, and then insert here. You see whether the movement capacity, that is the design movement capacity, is greater than 16 or not. And similarly, you have to adjust in bars right here, because if I'm using here 8 inch center to center, then what I have, then I will provide 16 inch will be here. If I use, let's say if I use 8 inch here, so 0.31 divided by 8 equals times 12, I got 0.46. Now at this time I got 0.465 inch square. Now I will plug this value here. What I got, already in my calculator the formula is active, so 0.62 I will be replaced by 0.465. Similarly, you must be able to do this calculation. Okay, 0.465, I got the moment 217 divided by 12, so 18 inches. This is very interesting. Okay, this is very interesting. 18 kept inch, which is greater than 16. So this means that I can change this reinforcement to 8 inch, and then this reinforcement will be 16 inch center to center. So this is how you can make economical design. Okay, now let's say moving forward, and this is now my middle strip. So in middle strip, you see here the bars which I am providing in this direction along the east-west direction. What is the movement right here? Okay, you see this is the corner. Okay, this is the corner panel, and the maximum movement here is 11.87, or you can say 12. Okay, so here I also represent those movements. Where are those movements? Here, this is east-west direction, and the maximum movement is 12. Okay, so this is positive movement. Now I am, let's say here what amount of steel I am using, number 5 at the rate of 12 inch center to center. These will be placed in east-west direction. These bars should be placed in east-west direction. Okay, one thing is very important, whether you have to place these bars, you have to place these bars in bottom layer. Remember, bottom layer means that here you see this bar is basically now in my east-west direction. Why? Because if we see here, we have 15, almost 12, 16 and 17, and if you see the bar, the demand of movement in this panel in north-south direction, so you see 12.3 to 8.8. so this means that the amount of positive movement is lesser than in east-west direction. So this is the reason why we have to place the bars along the longitudinal direction. Okay, although if this was a beam slab system, so you have to place these bars in the bottom, and those bars, the bars which are providing for this movement, will be on the top, or you can say it will be looks like in this shape. This bottom bar will be those bars. Okay, remember those bars which is provided for this movement, and the top bar will be now those bars which are provided for this. Okay, so this is the difference between flat slab analysis. Remember, this is a very important point, where which bar should be kept in bottom layer while which bar should be kept in top layer. This is very important. Okay, so please understand it. Now we are using number 5 at the rate of 12 inch center to center. If you check its capacity, I think so its capacity is around about 12 to 30 inches almost. Let me check it. Okay, let me check it from the same formula. Okay, from the same formula, if I am using, let's say here I plug 12, so I got 12 will be cancelled with 12, so I got this time 0.31. okay, now I plug that value here, as and as. So in my calculator already this equation is active. So I just replace the amount of steel, that is 0.31. so let me check it. 0.31, and last time I plugged 0.46. now this time 31. okay, I got 146 divided by 12, I got 12.23, and I already explained. Now this time I got 12, so 12 is more than the positive reinforcement. Here you see this 12, I got 12.23, so almost close, you can say 12.3, and I need basically 12, so almost we are close. So that's why I'm using number 5 at the rate of 12 in center to center. Okay, and then the east west direction. Further, what we have next panel. Here you see this is the column strip. This is the column strip, and in east west direction. Now here why I'm using the lesser spacing, because if you see here in this movement, the movement here you see this is 17. So for 17 I'm using again the same amount of reinforcement which I provide here. This is this reinforcement is number 5 at the rate of 6 in center to center. Let me check it. This one. Okay, so from this to this you see 6 inch. So this is number 5 at the rate of 6 in center to center. Remember, this is very important. Clear? This is very important. And the positive movement in this region, which is the middle strip region, is 17 kif. Okay, and similarly here we don't need, so I'm providing that amount of steel. Although here I can use number 6 at the rate of number 5 at the rate of 8 in center to center, and here the bar you see here, this is 12 in center to center. This is 12 in center to center. So let me check it. Okay, this is 12 in center to center. I think so. Yes, 1 feet or 12 inches center. So you can change this amount of reinforcement number 5 at the rate of this amount of steel, number 5 at the rate of 8 in center to center, and this one then will be number 5 at the rate of 16 in center to center. Similarly here, okay, similarly you can place this amount of steel to number 5 at the rate of 16 in center to center. But here now I am using number 5 at the rate of 12 in center to center. Okay, this is very important. And the rest of the work will be, here you see number 5 at the rate of 12 in center to center, the bar will be in east-west direction. Okay, and again, if you see here in the first exterior panel and in the first exterior panel, the reinforcement is a little bit complicated, but in the wrist, in this panel, and in this panel, the reinforcement is number 5 at the rate of 12 inch center to center. You can use number 5 at the rate of 16 inch as well. Okay, and one thing very important, you see ACI criteria says that you have to provide 2 bars within the column of the core. In column core you have to provide 2 continuous bars, so that's why I'm placing those continuous bar. Okay, if this is all about the rest of the calculation. Remember, in these external panels you have to just provide this extra amount of reinforcement, while the rest of the panel you see here, this is number 12 at the rate of 12 in center, sorry, number 5 at the rate of 12 in center to center. If you want to check it, so let us check it 1 feet. Okay, all amount of steel will be same. Okay, so not this one, let me check it, this one, this is not this one. Let me rub it, and again this to this 1 feet. So all the reinforcement is number 5 at the rate of 12 inch center to center. Okay, so this must be clear. Okay, and this will be in east-west direction. Similarly, in this middle strip, this is column strip, and similarly exterior. But in the first exterior panel, you have to a little bit change because there is greater movement. Now again, in north-south direction, this is the bottom layer of steel from positive movement in its direction. Remember, I already explained this point that this is this amount of steel now. Okay, we calculate these bars. Okay, we calculate these bars, which is number 5 at the rate of, in one place it is 6 inch center to center, while in all rest of the areas you have to provide 12 inch center to center. You can change this with 8, and you can change this with 16. Okay, now the next thing is in the north south direction, and we have to calculate now these bars which is placed over the bottom layer. Okay, this is the top layer over the bottom layer. Okay, now let me show you the rest of the bars placing. Here you have, this is the north south direction frames, and in the first exterior frame the bars which I am placing here is number 5 at the rate of 10 inch center to center. And what is the movement right here? So you need to go to the north south direction. Here we have, this is north south direction. Okay, and you can see here 10.4 say 11, we have to place bars now for this moment 12 or 13. So this is positive, here is the negative. So in middle strip we will increase the spacing, and the column exterior strip, this is column exterior strip, we will decrease a little bit, and here again we will decrease the spacing. So let me show you here, this is north south direction. Okay, so here we have positive movement 12 point, this one 9 and 13. You can provide uniform bars for all these reinforcement. Let's say I will design for 13 and provide the same amount of steel to this bar, to this bar. Okay, to make things simple. Okay, but here you see I am using for that 12 number 5 at the rate of 10 inch, for that 9 I am using number 5 at the rate of 12 inch, and for that 13 I am using number 5 at the rate of 10 inch. This is in column strip. Okay, although this amount of reinforcement is maximum, you will be allowed to use, let me show you. Here you see, if you use let's say you will use 12 inch center to center, so you see the amount, the UR will be on the same side. So so that's why I'm using, although I'm using 10 inch, but you can use 11 inch as well as 12 inch as well instead of this 10. And similarly for 9 you can use 13, 14, 15 inches as well. Okay, so but I'm using this amount of reinforcement, and through all panels. Okay, through all panels. Now remember, this number 5 at the rate of 12 inch center to center will be provided in this middle strip. Similarly, this number 5 at the rate of 10 inch will be provided in this column strip. Similarly, in this middle strip, this is the middle strip. Okay, the middle strip, remember, it starts from this point to this point. Remember, it starts from this point to this point, and remember, this is very important. And similarly, the distances of the column strip and already we calculated. Okay, and yes, one thing is very important, that for, remember, you can calculate its cut up point or cut up length. You can say this is cut it at a distance of L by 3, and this is cut it at a distance of L by 3, but I am providing although L by 3 is round about 5 feet 6 feet roundabout. Okay, so we will cut the bar from the face of the column at that spacing. Okay, so this is all about, remember, this is the now the complete detailing, that in north south direction the bar is placed in column strip. In interior column strip is number 5 at the rate of 10, while in middle strip number 5 at the rate of 12 inch. But in exterior panel, exterior frame, this is number 5 at the rate of 10 inch center to center. So if I draw a cross section, okay, here we have a cross section. Okay, here we have a cross section for bottom bars only, not for the top. Remember, just for bottom. So you see the bars is placing in the middle, this red line basically representing the column strip width. So here you see number 5 at the rate of 12 inch center to center, already I explained it. And in the middle you see you have 2 layers, we have double layer, so that is number 5 at the rate of 6 inch center to center. So the spacing is decreased. Now again here you see in the column, these 2 red lines basically are the column strip width, and I provided number 5 at the rate of 12 inch center to center. Okay, but in the same region you see these dots, these are the bars which will be in the north south direction, and in the north south direction this is number 5 at the rate of 10 inch center to center, and here I already explained it. Okay, here you see number 5 at the rate of 10 inch center to center. and this is number 5 at the rate of 12 inch center to center. And here you see, let me show you, this is number 5, and this is these darts. Basically these darts are placed at a distance of, let me check it whether it is okay, from this point to this point. This is 1 feet. So that's why these bars are 12 inch center to center, and similarly here the main bars, which is at the bottom bars, and number 5 at the rate of 12 inch center to center. And let me show you here, you see number 5 at the rate of 12 inch center to center, and in this exterior frame number 5 at the rate of 10 inch center to center, and here you see number 5 at the rate of number 5, this line, okay, number 5 at the rate of 10 inch center to center, these dots, okay. So in the column strip the distance is minimum, while in the middle strip the distance is more. Now this is all about the bottom reinforcement or the positive reinforcement, okay. Now we go towards the negative reinforcement, which will be the top layer now, okay, which will be the top layer now. Now we are basically designing for this 2 layers of steel, okay, these 2 layers of steel. This 2 layer of steel, this is very important, okay. Now first of all we will place in north east west direction for negative reinforcement, east west direction, and then we place these bars in north south direction, okay, similarly as we did here. So we start from the corner column, and let me check my movements, okay. Here I have movements, you see the negative movements. Now this is north south, but I did calculation for the east west direction. So in the first corner column the negative movement is 14, negative 14, and similarly here this is minus 28. Let me show here, this is north south direction, and in east west direction I rounded things, okay, to make it simple. Now minus 14 and minus 27, I have to place bars now for this movements, minus 14 and minus 27. What I placed, so this is my reinforcement detailing in north south direction, and this is now, okay. Here you see the top layer steel for negative movement in east west direction. So the bars will, now we are placing basically bars for negative reinforcement, okay, for negative reinforcement in east west direction, okay. And let me show you the diagram again. This is the diagram, okay. For this negative movement we have to place bars in east west direction, and for this negative movement we have to place in east west direction. But remember that this is the top reinforcement, this one. Now this bars, first of all we calculate the top bar, and there you see that is placing in the top portion. Why in the top portion? I will show you the reason. And this is the bars, cross bars, which is basically provided in north south direction, okay. Now we are starting the calculation from corner panel, okay. And here we have in east west direction minus 14 and minus 27, again minus 25, again minus 25, minus 27 and minus 14. Now ignore these values, okay. Now ignore these values because we already designed for these moments, so you don't need to be confused, okay. You don't need to be confused with these values, okay. We just did the calculation, we provide the reinforcement for these moments, okay. So you must get these, okay. Now minus 14, what amount of steel I am using for minus 14? Here we have already explained, this is east west direction, and the bar placing which I am providing in the east west direction, these bars are placed number 5 at the rate of 8 inch center to center. And if you are providing with 8 inch center to center, whether it will cover the movement or not. So I already did the calculation here. You see here, if I am placing number 8 bar, number 5 at the rate of 8 inch, so here I have to place 8, and it will give me the amount of steel, that is 0.465. And when I did the calculation, it gave me a moment of 18, which is already greater than 14. So this means that I am eligible here to place the bars at number 5 at the rate of 8 inch center to center, okay. Although negative movement is minus 14, but the capacity of this reinforcement is 18. Now remember, this is placed in the column strip width. Okay, let me show you. This is placed in the column strip width. This is the column strip. Okay, let me show you. Okay, this is the column strip. Okay, this is the column strip, and you know about the length of this column strip. Okay, now if I draw the cross section of this bar, let me draw the cross section, because I'm not drawing the cross section. So here, let's say this is my reinforcement detailing, and this is in east-west direction. Okay, east-west, as well as we will north-south direction. Okay, so the first bar, remember, let's say this is the edge of the slab, and this is my corner strip or column strip, sorry, and this is my now middle strip. Okay, and this is my, again I have a column here. Okay, I have a column here which is continued, similarly which is continued, and again I have slab which is continued. Okay, and this is my column strip width for my my interior frame. Now the first top bar will be hooked, and it will be placed for a distance of column strip. Okay, now you see the next movement is now the next movement, that is the negative. Now I have to place bars for -27. So what amount of steel I am providing for -20? You see, this is the a heavy demand. Number 5 at the rate of 4 inch center to center. Okay, number 5 at the rate of 4 inch center to center. And if you are interested to find the movement capacity of number 4 at the rate of 4 inch center to center, so you just need to change this 6 with 4 and did the calculation, and then that steel area will be plug here, and you got the capacity. Okay, that is more than 28. Okay, I think so, that will be more 29 to 30 roundabout. Okay, so that's why I'm using this close reinforcement. This is number 4, the rate of 4 inch center to center. But in the middle portion, you see, theoretically we do not need any reinforcement in the top, okay, portion. Already I explained it. Okay, here, because there is no positive movement in the top, here I have to place this main bar in the top region, remember, and this bar is basically number 5. This is number 5 at the rate of 4 inch center to center. Okay, this is number 5 at the rate of 4 inch center to center, and this bar is basically this one. This bar, this is number 5 at the rate of 8 inch center to center. Okay, in the east-west direction, but we are providing the bars right here. Okay, already we don't need. Okay, but we are providing minimum reinforcement. Okay, so that placing will be 16 inch center to center. Okay, you see here, and the reason that why I'm using 8 inch center to center, because here I am getting 16 inch center to center, and in the whole panel, remember, in the whole panels, you see this white line. Okay, you see here, and here I am writing number 5 at the rate of 16 inch center to center. So this is very important, and this bar should be provided in the top. This bar, remember, in between these, from this point to this point, this amount of steel is number 5 at the rate of 16 inch center to center. Okay, this is in the middle strip, in north-south direction. Now, sorry, in the east-west direction, sorry, in this direction. Okay, in the east-west direction. And then again, you see here this amount of reinforcement. This is, you see here, this is I think so, number 5 at the rate of 8 inch center to center. And here let us check the movement. Okay, the movement here in this place, the movement, this is -10, -10, -10, -10, and -10. So to cover that -10 movement, I am using number 5 at the rate of 8 inch center to center. Okay, so this must be clear. This amount of steel, this one, these bars, and the circle, you see, this bars is basically, these are the bars. Okay, and yes, these are the bars. Please trim it. TR double enter. This should be cut it. Okay. And for this movement, I am using number 5 at the rate of 8 inch center to center. Again, in the interior column region, I am using again number 5 at the rate of 4 inch in the east-west direction. And similarly here, the movement is minus, the movement here is the movement minus 14. So for that minus 14, again I am using number 5 at the rate of 8 inch center to center. And the rest of the things you see number 5 at the rate of 16 inch center to center. Okay, here although yes, here I am also using, okay, in this 10 feet which is the middle strip width in east-west direction, I am using number 5, but in the column strip number 5 at the rate of 8 and the column strip this move. Similarly again you see in the middle strip number 5 at the rate of 16, while in the column strip number 5 at the rate of 8 inch center to center. Okay, again you see here in this middle strip number 5 at the rate of 16, again in the column strip number 5 at the rate of 8 inch center to center, again that one, and similarly for interior, here we have in east-west direction number 5 at the rate of 4 inch, again in the middle strip, this is the middle strip number 5 at the rate of 8 inch center to center. Similarly here, and you see, I think so this is easy, okay, to understand. Now and same things, this panel will be now repeated here again and again, and you see the placing right here. So again you see here all the detailing, okay, for this exterior will be same like the first one, okay, and watch this detailing how I place the bars, okay, and again in the middle strip you see number 5 at the rate of 16 inch center to center. So these are the top reinforcement in the east-west direction. Now we are moving toward in the north-south direction. This is the north-south direction. Remember the top layer for negative movement in the north-south direction. Remember here we have, you see, we place the bar in east-west direction. Now the bars which is provided cross bars which is provided now over this reinforcement will be at how much distance, meaning that we will now calculating these east north south direction bar, these bars, okay. So this is the top layer and top surface of the you can say the top surface of the slab, but this is the bottom layer. Although top we designed for negative, now we are designing bottom. Now here you see in the if you coming to this slide, you see here the negative in the north south direction, the negative movement is minus 11, and here we have 0 negative, okay. So in the middle we have 0, and but here we have minus 5.13 which is very small amount. Here again we have minus 11, and here we have maximum amount of steel. So let me show you in detailing. This is the east-west direction, and in the north-south direction you see here north-south direction the movements are minus 11. Now we design for these positive movements. Now skip these movements, okay. Now skip these movements. This is very important. You don't need to be confused these positive movement, okay. So you have to skip these movements, okay. Now for minus 11, what amount of steel I am providing? Let me just show you. You see for 11 I am using number 5 at the rate of 6 inch in the north-south direction. In the north-south direction I am placing number 5 at the rate of 6 inch, which is heavy reinforcement you can say, because number 6 it give me movement capacity of I think so 18 to 23, round about 23, okay. This one 23 almost, this is heavy reinforcement, and you can say this is uneconomical, but you can change this although we have 11 inch movement, so you can change this amount of steel to 8 inches, okay, to 9 inches you can go and check the capacity, okay. But if you are using number 5 at the rate of 8 inch, then this steel, okay, in the middle strip, okay, in the middle strip of the east-west direction, okay, this steel, okay, let me show you. Although these bars length should be this from this point to this point, okay, this is the column strip, but In the middle strip, okay, the bars which is placed here, this is 10, this is number 5 at the rate of 12 inch. If you are change this to 8, then it will be 16. Okay, so you here you have flexibility. Okay, but remember, theoretically we don't need this amount of reinforcement in the positive region. Okay, but we are providing the minimum reinforcement. Okay, and again here we have, I am using again that reinforcement. So basically students, we were explaining, sorry for some kind of interruption, I completed okay this video. Here we are basically that we explain this number 5 at the rate of 6 in center to center spacing. Now one thing is very important, you see that here we are also providing number 6 and number 5 at the rate of 6 in center to center. This is very important to understand, okay, that although I don't need this heavy amount of reinforcement here, although there is 10 feet movement, okay, so I can control this by number 5 at the rate of 9 inch, or you can say 11 inch, 10 inch, okay. But why I'm using here, that the reason is that although there is theoretically no need of any reinforcement, but here we have to provide this amount of reinforcement because the movement right here is 20 feet. Let me show you. The movement is you see here, this is a north-south direction, and the movement you see, this is 20. So that why to control 20 feet movement, we have to place bars at the rate of 7 or 6 in center to center. Okay, so that is the reason, because I can use here number 5 at the rate of 8 in center to center. Then I have to change this to 16 in center to center. But then again, here is problem. If those bars are coming from that side with a spacing of 16 inches center to center, then how can I adjust here? Okay, here I have problem. Okay, because in 16 inch I can place 2 bars with a different spacing, like you can say 16 divided by 2, so that will give you 8 inch roundabout. So 8 inch not covering my movement, so here basically is problem for me. Let's say try, this is 16 inches, let's say this is 16 inches, so then 16 divided by 2 mean 8 inch, so 8 inch not covering my 20 kick movement, so that why I am bound here to use this amount of spacing. Okay, or if you are using here 8 and 16, then you have to defer your change your spacing. Okay, but you may not increase the spacing more than 6 in center to center. Okay, so this is a simple arrangement which I can use here. Similarly, here I am also using this amount of steel, number 5 at the rate of 6. Here I am using number 5 at the rate of 6, and in the middle you see number 5 at the rate of 16, and here we have number 5 at the rate of 10 inch, 12 inch center to center. Although I don't need the reinforcement, but here is negative movement is 0. Let me show you. You see basically the movement is, the negative movement here is 0. Where is the other diagram? Let me show you diagrammatically. So here you see the negative movement is 0. Right here it is 0 in north south direction. Yes, let me show you here. This is north south direction. So you see that this is a north south direction. I am placing bars in north south direction. Okay, and in the top portion you see there we have no negative movement, so that's why although this is a top reinforcement. Okay, and as I'm show you the section of this. Okay, so here we are basically drawing the section, and see in the column, if for example if I cut a section right here, okay, let me draw a section. Let me I cut a section at this location, and at this location, let's say, one point here, and again I'm looking to this side only. Okay, now for example, if I'm looking to this side in this direction, okay, I'm looking in this direction, so you see here in the north south direction, in the north east west direction, basically here I am placing in the east west direction number 5 at the rate of 8 in center to center. These are the negative bars in the column strip. So you see this is number 5 at the rate of 8 inch. Now the cross bars I am providing in downward direction, although question arises why not you are placing in the top of these bars, because this is greater amount of steel as compared to that one. Now the reason is that in that direction you see the movement is maximum. Let me show you diagrammatically. I will show you the variation. Okay, you see in the north south direction there is almost 11 feet movement. Okay, and in the north, this is in north south direction, but in the north east west direction you see 14. So larger amount of movement is transferring in the longitudinal direction. So that why I'm using the bars in that direction, and the cross bars basically in the downward direction. This is the reason. Okay, you must understand this reason. And this is not basically in the case of beam supported slab. In beam supported slab we have to place these bars on the top, because we are providing the bars near the top or bottom surface in the shorter direction, and that's basically, this is the main difference. Okay, this is the main difference. And the other let me show here in this cross section. So these bar spacing in the column strip, within the column strip, this is number 5, okay, at the rate of 6 in center to center. Okay, this is 6 in center to center, although the top bars are 8 in center to center, but you do not to be confused. Okay, although we can provide this as a 8 inch center, but I already explained that we are bound to use that. Okay, this amount of reinforcement we cannot change this, because in next panel it creates trouble for us. Okay, and the next, in the middle strip, basically in the middle strip in the top region, although theoretically we don't need, okay, because no need of movement, but we are using minimum amount of steel, that is for both. Remember, this is number 5 at the rate of, but the top bars, I think so the top bars are yes, you don't need in the top bar, so in both layer we are using number 5 at the rate of 16 in center to center. Here you see cross bars number 5 at the rate of 16 in center to center, and here you see these bars, okay, these bars are basically number 5 at the rate of 16 in center to center, and here I am showing you. Okay, so you must clear these points. Clear? Now the next, and then the rest of the reinforcement detailing here 6 in center to center, and for all this in this middle strip we are using number 5 at the rate of 16, here number 5 at the rate of 6, here the number 5 at the rate of 12 in center to center, remember. And in the last panel we will use this reinforcement here, number 5 at the rate of 6, number 5 at the rate of 12, number 5 at the rate of 6 in center to center. Okay, so this is the detailing for top reinforcement. Okay, you see here top layer steel for negative movement. Now if we combine these two diagrams, okay, these two diagrams, so what we have then this, we got this one. Okay, now this is the reinforcement, both top and bottom layer of steel in NS and east-west direction. This is the combined result when we are basically combining the bottom bar detailing as well. Now we are combining the bottom bar detailing as well. Okay, so we are now doubling the mesh. Okay, so how it looks like, see in the corner panel, this is our corner panel, you see the red bars are in east-west direction, and those bars, you see this bar, okay, this one, you see these bar detailing is number 5 at the rate of 8 in center to center. Okay, and these are the, remember, these are the bottom bars. Yes, these are the bottom bars, and these are the top bars. Sorry, these are the top bars. These are the top bars. Let me show you in cross section. Here we have a cross section. Okay, here we have a cross section, and you see these are the top bars, negative number 5 at the rate of 8 inch center to center. The next one is the bars which is perpendicular to the blue bars, which is perpendicular to the red one, and you see that is number 5 at the rate of 6 inch center to center. And you see in the cross section here, okay, these dots basically which is provided in the top, these are number 5 at the rate of 6 inch center to center. Now these bottom bars are I think so it is not represented here. This detailing is for top and bottom reinforcement, I think so. Okay, but in the bottom bar detailing I already explained, this I already explained. This is number 5 at the rate of 12 inch center to center, and this is number 5 at the rate of 6 inch center to center here in the middle. Okay, in the middle strip, and I explained this here. Okay, here you see. So already I explained this cross section, but you must know the detailing of the top reinforcement. Remember, in the middle strip I'm using number 5 at the rate of 16 inch center to center both way in the middle strip, while you see here in the column strip you see the top bar are number 5 at the rate of 4 inch center to center, and I already explained this here. Number 5 at the rate of 4 inch center to center, and the cross bars to those bars, these are blue bars, number 5 at the rate of 6 inch center to center. And here you see these blue bars are number 5 at the rate of 6 inch center to center, and similarly blue bar and red bar, these both are number 5 at the rate of, I change here, that is 15 inch center to center. Okay, these I will change. Okay, but in the cross section I am showing you this is 15, although we can use it as 16 inch center to center. So let me change this. Okay, this is almost 16 inch. Okay, double click on it and change it. This is 16 inch center to center both way. Okay, both way, in this direction as well as in this direction, but in the top layer. Remember, these are the top bars, and similarly you can see the whole detailing. Okay, these are number 5, these, okay, this bars in the east-west direction, number 5 at the rate of 4 inch center to center, and similarly these blue bars which are placing, let me show you from within the column strip. Remember, within the column strip these bars will be number 5 at the rate of 6 inch center to center. Okay, 6 inch center to center, and remember this will be these yellow bars, okay, which is placed in this direction, and these number 5 will be placed in east-west direction. Okay, so similarly here you see the bars basically, which is, remember, these are the top bar, let me show here, not this one. Okay, this one will be, here you see, okay, it is not clear here. Okay, it is not clear here. These bars, okay, these, remember, these blue bars basically, you see the bar which is placed in this direction will be number 5 at the rate of 8 inch center to center in this direction. Okay, while these blue bar is basically number 5 at the rate of 12 inch center to center, and where I show it here. Okay, here you see number 5 at the rate of 12 inch center to center, these blue bars. Okay, so you don't need to be confused. Okay, and these are the cross bars basically, and the cross bars, okay, number 5 at the rate of 16 inch, here number 5 at the rate of 16 inch, okay, but these are the crossbars, red bars, okay. And okay, here is also you see the bar detailing. Remember, okay, let us change this. Now you see here we have two layers, okay. The blue bars basically which is provided in this direction is number 5 at the rate of 12 inch into the center, and it is clear from here, okay. Number 5 at the rate of 12 inch into the center, and the bars which is right above these bars are the red bars. These are number 5 at the rate of 8 inch into the center, I think so. Let me check it here, these bars, okay. And this is the detailing of this reinforcement here, number 5 at the rate of 8 inch into the center in the east-west direction. Clear? So basically I combine this and these two layers, but these two layers are basically for the top surface, not for the bottom surface. And for the bottom surface you will use these, you have to combine this map with this map, okay. So this is how we can show the detailing. This is the cross section, okay. And here I am showing you the plane. Basically this is top layer steel, okay. I already discussed it. And similarly you see these are the shear reinforcement. So this is very important. I want to discuss the shear reinforcement, okay. Now this is the bar which you see both top and bottom layers are combined here. Now the shear reinforcement is very important. You see at the edge, basically if you watch lecture number 11, okay, in lecture number 11 I basically explained the shear reinforcement. The shear reinforcement detailing is just only for the interior column, although you need to check for this edge column and for this corner column, but I think there will be no need of a punching shear reinforcement. This is all for the punching shear reinforcement. And please watch lecture number 10 and 11 which I already uploaded, okay. So here you see the detailing of this punching shear will be right here, okay. And let me show you in my AutoCAD, okay. Here you see the detailing. This is okay, this is the detailing. You see here these are the concealed beams, okay. If I want to show you if I want to show you a picture or a video regarding to this detailing, so this video is very important to understand basically the punching shear detailing, okay. So you see here, basically you see here that this is the shear reinforcement for punching, okay. So here the punching shear is dominant, and you see here basically we are determining the distance of the beam for which it is overhang, okay. And the stirrups detailing I already designed it in lecture number 11, okay. And I want to show you one picture as well, so you got an idea. Remember, we have to find out this length and we have to find out the stirrups which is placed in this beam. These are the concealed beam, okay, and the spacing of these stirrups, okay. So here you see the detailing, okay. The bars which is extended from the surface, from the face of the column, is for a distance of 2 feet, and similarly in that direction. And the column size is 14 inches. And remember, just leaving 1.5 inch clear cover to this side and this, okay, you got, I think so, 1 feet roundabout width of this beam, and its effective depth I think so 9 inch, okay. So here you see all the interior columns are reinforced with shear, okay. And here you see the detailing, okay. And the spacing of the stirrups, you see number 3 at the rate of 3 inch center to center, okay. And if I draw a section, okay, you see the section. Remember, internally we have to provide a beam in this direction, in the east-west direction, as well as in north-south direction. And the bars, this bar, this bar, this bar, these are the number 4 bars. Number 5 bars, 4 numbers. And remember, these are the same bars which are basically you have to provide along your column core. I already explained this. SEI criteria says that you have to provide minimum 2 bars in the core of the concrete. So I am providing here basically two bars in the top and in the bottom. So those bars will be work like a shear reinforcement at the area punching shear area. Okay, so I will provide stirrups, and those stirrups is basically controlling the crack. Okay, so this is all about the shear reinforcement or punching shear, and already I explained thoroughly in lecture number 11, so please watch that lecture. Okay, in the last basically I will share a video which will explain the whole placing and detailing of this kind of reinforcement both in top and bottom layer. So now inshallah you will see the video.